Welcome all of you on chemistry study channel Chemiluminescence. In this session we are going to discuss about halogen derivatives. Let's see first how much weightage this unit have in board exam. Approximate mass is given. Without option this unit have 4 mass. With option this unit have 6 mass. What we will study in this unit? First we will study introduction of halogen derivatives, then classification of halogen derivatives, then nomenclature of halogen derivatives. There are two systems by which name of organic compounds are decided. First one is a common name system and the next one is a IUPAC name system. We will study both of them. Then the next we will study method of preparation. In this we will study different methods of synthesis of halogen derivatives. After this we will study physical and chemical properties of halogen derivatives, and the last one we will study uses and environmental effect of the halogen derivatives. Means whether you show positive impact on environment or a negative impact on environment and their usefulness. Let's see first what is halogen. Halogen is represented by capital X. In periodic table, group 17 elements are called halogens. We know there are total 18 groups in periodic table. Group 18 elements are most stable elements because their outermost shell is completely filled, and these halogens belongs to group 17, that is they required one electron to complete their outermost shell. Hence general electronic configuration of this halogen is NH2 and P5, and because of this they are most reactive elements in the periodic table. Do you know which elements are present in group 17? Fluorine, chlorine, bromine, iodine and astatines are belongs to group 17. There may be one more artificially synthesized element named tennessine having symbol TS. Here you can see fluorine having symbol F, chlorine having symbol Cl, bromine is represented by Br, iodine is represented by capital I, and astatine is represented by AT. If you knew group 17 elements name and symbol, that's very good, but if you don't know it, I am giving you short mnemonic to memorize group 17 elements. If you memorize this small sentence, you will able to write symbol of halogens. From that symbol you can write the name of element. The short mnemonic to learn halogen is first class biryani I ate. What you have to do? You have to learn or memorize this small sentence, and if you learn it, then each and every word present in this is represent a symbol of halogens. First word, that is first, in that F is for fluorine, in class Cl is for chlorine, in biryani Br is for bromine, in I is for iodine, and AT is for astatine. So that is for by learning this or by memorizing this small sentence, you can easily write the symbols of halogen, and from that symbol you are able to write the name of halogens. Next we'll see what is derivatives. The derivatives are compounds formed from parent compound by replacement of one or more atoms or group of atoms. Derivatives are synthesized from parent compounds by replacement of one or more atom or a group of atoms. Let's combine this. We'll see what is halogen derivatives. With the help of equation, we'll see what is halogen derivatives. In this equation, the hydrogen atom of methane is replaced by halogen, and the product is formed is methyl halide. This methyl halide is a derivative of halogen. Why it is a derivative of halogen? Because the one hydrogen from parent compound is get replaced by halide or halogen atom. That's why whatever the form, this is the product. This product is halogen derivative. So the definition of halogen derivative is this one: when a hydrogen atom or atoms of aliphatic or aromatic hydrocarbon are replaced by corresponding number of halogen atom or atoms, either chlorine, bromine or iodine, the resulting compound are called halogen derivatives. So from this you will understand what is halogen derivative. The halogen derivatives is synthesized from parent compound, either they may be aliphatic or aromatic. Aliphatic, we know that aliphatic is nothing but it is a hydrocarbon which are further classified into saturated and unsaturated. Saturated means that compound which contain carbon-carbon single bond, and the unsaturated, that means which contain carbon-carbon double bond or a triple bond. If the hydrogen atom of these aliphatic or aromatic compounds are replaced by a halogen atom, the resultant compound is called halogen derivatives. Next we will see the classification of halogen derivatives. Halogen derivatives are classified into two ways. First one is on the basis of hydrocarbon skeleton, means how the hydrocarbon chain looks like, whether it contain carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond, or it contain aromatic compound. On the basis of that, it is further classified into haloalkanes, haloalkenes, haloalkynes and haloarenes. Let's see one by one. First one is a haloalkane. Haloalkane is a compound in which hydrogen atom is bonded to alkane compound. Alkane compound is, we know that alkane compound is nothing but the, in simple way you can say that hydrocarbons in which all carbon-carbon atoms are bonded by a single bond. So let's see the example. This is the example of haloalkanes. In this you can see the halogen atom is bonded to that carbons which is bonded by a carbon-carbon single bond. That's why it is the example of haloalkenes. The next one is haloalkenes, the compound in which halogen atom is bonded to alkene compound. Alkene compound is nothing but the carbon-carbon doubly bonded compound, or a compound in which carbon-carbon double bond is present. This is the example. In this you can see this halogen atom is bonded to that compound in which carbon-carbon double bond is present. The next one is a haloalkyne. Again the same definition is there, the compound in which halogen atom is bonded to alkyne compound. Alkyne compound means a carbon-carbon triple bond compounds. So the hydrogen atom of this alkyne is replaced by halogen. That's why this is the example of haloalkyne. And the next one is a haloarene. Arene word is used for aromatic compounds. The simple definition will be halogen atom which is bonded to aromatic compound. That means a compound like benzene, or a compound in which benzene ring or aromatic compound is present. This is the example of haloarenes. The next way of classification is on the basis of number of halogen, is how many halogens are present into the compound. On the basis of it is classified into a further few more types, that is mono, di, tri or polyhalogens compound. So the name itself shows that how many halogens will be present in that compound. Let's see with the help of example. Monohalogen compound. In this you can see the compound in which if one halogen atom is present, that is the example of monohalogen compound. These two are the examples of monohalogen compound in which one halogen atom is present. In dihalogen compound, the compound in which if two halogen atoms are present, that compounds are example of the dihalogen compound. In trihalogen compound, if three halogen atoms are present in a compound, that is the example of trihalogen compound. You can see here that this compound contains 3 halogen atom. Here also this compound contains 3 halogen atom. And a polyhalogen compound is the compound in which more than 3 halogen atoms are present. That are the examples of polyhalogen compounds. Now further classification of monohalogen compounds. So monohalogen compounds are further classified on the basis of position of halogen atom and the type of hybridization of carbon atom. Means where the halogen atom is present and to which type of carbon it is attached. Either it is attached to sp hybridized or sp2 hybridized or sp3 hybridized. On the basis of that it is further classified into few more types. So first one is that alkyl halides or haloalkanes. The alkyl halides in which when the halogen atom is bonded to sp3 hybridized carbon atom. sp3 hybridized carbon atom is nothing but the saturated aliphatic carbon atom. In that in simple way we can say that singly bonded carbon atoms. So if the halogen atom is attached to sp3 hybridized carbon atom, that is called alkyl halides. It is further classified into again 3 types, that is primary, secondary or tertiary, depend on the substitution state of the carbon atoms. How many alkyl group is attached to that carbon atom to which halogen atom is bonded is further classified into few more types, that is primary, secondary or tertiary. Let's see one by one. Primary alkyl halide. This is the example of primary alkyl halide. Here you can see that this halogen atom is attached to that carbon which is a primary carbon, and primary carbon is nothing but the carbon which is bonded to one another carbon atom. This R group represent alkyl group, that is hydrocarbon group. So this carbon is bonded to one carbon atom, that's why this green carbon is a primary carbon. And if the halogen is attached to a primary carbon, this is the example of primary halide. This is the definition of primary halide. Next, that is secondary halide. The example of secondary halide is this one. Here you can see that this halogen atom is bonded to this carbon atom, and this carbon atom is a secondary carbon. Why it is secondary? Because this carbon is attached to two more carbon atoms. These are the carbons. This is the alkyl group, and we know that the alkyl group contain is nothing but the hydrocarbon groups. So this green carbon is bonded to two more carbon atoms. That's why this green carbon is secondary carbon, and this halogen is bonded to this secondary carbon. That's why this is the example of secondary halide. This is the example definition of secondary halide. Now the next one is tertiary halide. From these two you can predict what will be the tertiary halide. So the tertiary halide is the compound in which halogen atom is bonded to tertiary carbon atom. And what is tertiary carbon atom? The tertiary carbon atom which is attached to three other carbon atoms. So this is the example of tertiary halide, and the definition is this one. Now the next one is a allylic halide. In allylic halide, halogen atom is bonded to allylic carbon. So which carbon is called allylic carbon? The carbon which having hybridization sp3 and which is next to the carbon-carbon double bond is called allylic halide. And if the halogen is bonded to this allylic carbon, that is called allylic halide. In next example also you can see this yellow shaded carbon is the allylic carbon because it having a hybridization sp3 and it is next to the carbon-carbon double bond and to which halogen atom is bonded. That's why this is also called allylic halide. This is the definition of allylic halide. Next is a benzylic halide. These are the examples of benzylic halide in which the halogen atom is bonded to benzylic carbon. Which carbon is benzylic carbon? The carbon which having hybridization sp3 and which is directly bonded to benzene ring. In both the example you can see the halogen atom is bonded to these green carbons which having hybridization sp3 and which is directly bonded to benzene ring. That's why these are the examples of benzylic halide. This is the definition of benzylic halide. Next one is a vinylic halide. In vinylic halide, the halogen atom is bonded to this green carbon, and this green carbon having hybridization, it having a double bond. That's why it having hybridization sp2. If halogen atom is bonded to sp2 hybridized carbon atom is called vinylic halide. In second example also you can see this is a cyclohexene ring in which halogen atom is bonded to this yellow shaded carbon and which having hybridization sp2 because it is doubly bonded carbon. So this is also example of vinylic halide, and the definition is this one. Next one is a haloalkyne. It is very simple. Alkyne, we know that alkyne is nothing but the carbon-carbon triple bond. When the hydrogen atom of alkyne is replaced by halogen is called haloalkyne. And in that what will be the hybridization of the carbon to which halogen is bonded? Having a sp hybridization. So when a halogen atom is bonded to sp hybridized carbon is called haloalkyne. This is the definition. And the next one is aryl halides or haloarenes. The aryl word is used for aromatic compound. Again the arene word is used for aromatic compound. The name itself shows that what will be it. So when halogen atom is bonded to arene, that is aromatic compound, is called haloarenes. This is the example. Means when halogen atom is directly bonded to aromatic compound is called aryl halide. So this is the example or definition of aryl halides. So this is all is the classification of halogen derivatives. Hope you will understand it. If you understand it, then like and share this video and subscribe this channel for more videos. Thank you.